Hello everyone, in this video, we're gonna cover 2024 AIME 2 problem number 6. All right, so here we go. Let's read the question. Alice chooses a set A of positive integers. All right, so Alice chooses some numbers, I would say, on integers. And that would be the set of integers that we have. We don't know how many integers that Alice has, but hey, that's what we have found. And Bob lists all finite non-empty sets B of positive integers with the property that the maximum elements of B belongs to A. All right, so we probably got to use some inductive reasoning. Now, what's the inductive reasoning? Well, we got to try out some base cases and figure out certain patterns that's going to come out, right? So we're going to use certain patterns out of these, out of these examples, and probably we got to use some basic numbers, like small numbers, small set of numbers, and try to see what happens. And Bob's list has 2024 sets. All right, so find the sum of the elements of A. Okay, so what if Bob wants to say, hey, X1 is going to be my maximum element. So I want to try out something like X1 being something like, for instance, if I say, like 2 and 3 and 5 and so on, that could probably be working out for Alice's set. Now, if 2 becomes the maximum element of B, well, I can come up with something like 2, or I can come up with 1 and 2, and that's it. Now, what about what happens for my maximum element of B happens to be 3? Well, I can come up with something like 1 and 3. I can come up with 2 and 3. And I can come up with 1 and 2 and 3. Or probably I can come up with just 3. Now, that tells me that this is going to be permutation allowing repetitions, right? 1 can be in it or not. 1 can be in it or not, 2 can be in it or not, and that's it. So we kind of noticed that, probably out of these observations, like thanks to these observations, we gotta figure out how many, the powers of 2 that it has. So for instance, if X1 is certain numbers, well, let's say like 2 or 3 or 4, it's gonna be 2 to the power of X1 minus 1, right? And of course, X2 might be just 1 bigger than X1, or maybe 2 bigger than, X1 or the previous numbers, but we got to make another observations for the third number. All right, so that becomes 1 and 2 and 3 and 4 and 5. That's a maximal possible, the maximal set that we can come up with such that its maximum value becomes 5, and we got 2 to the power of 4. So we have 2 to the power of 2 and 2 to the power of 1. Okay, so we have 2 to the power of 1 and we got 2 to the power of 2. So depending on certain numbers that we can write down for X1 and X2 and all the way to Xn, well, probably we can use those powers that's gonna go, that keeps increasing with certain differences of all those values by 1. Okay. All right, so we have 2 to the power of something, 2 to the power of, I don't know, probably, I'm hoping for the best, right? We're hoping for the best that this would work, and such that becomes 2024. All right, so let's see whether that works, okay? Let's see whether this would work out. And I think I need to first figure out the prime factorizations of 2024, or probably I got to take out just powers of 2 out of it. So if I say 2 times 1012, and that becomes 4 times 506, and I can say 8 times 253. Well, that's the first time we ever get an odd number. All right, so we got to think, how on earth am I going to make 253 in terms of powers of 2s, the sum of powers of 2s? Well, I know that 255, well, first 256 is going to be 2 to the power of 8, right? So 255, well, that's just going to be 2 to the power of 7, 2 to the power of 6, 2 to the power of 5, and ... all the way to 2 plus 1, okay? All right, so we have all of these, and 253, what's that? 253, I just got to cancel out, I just got to take out that little 2. So we got 2 to the power of 7, 2 to the power of 6, 2 to the power of 5, and ... all the way to 2 to the power of 2 plus 1. Okay, so let's use this fact, right? So whatever that we had here, let's just try to move this, whatever things that we have here on that x1 and x2 and all the way up to the Alice's expressions, well, we got 2 to the power of 3 times 1 plus 2 to the power of 2 and 2 to the power of 3, and it keeps going up all the way to 2 to the power of 7. Okay, so that implies that we have 2 to the power of 3 and 2 to the power of 5 and 2 to the power of 6 and dot, 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 all the way to 2 to the power of 10. Let's just try to think about, just shrink this a little bit. Let's just try to think about what has happened for one-to-one correspondence. All right, so here we go. 2 to the power of 1 has been corresponding to 2. 2 to the power of 2 was corresponding to 3. 2 to the power of 4 was corresponding to 5. So I got 2 to the power of 3. That's going to be my x1. Well, that must be 4. And what about 2 to the power of 5? You can say that 2 to the power of 5 was corresponding to probably 6, right? Why? Because 2 to the power of 4 was corresponding to 5. So that must be 6 and 7 and 8 and all the way up to 11. And if you take the sum of all these values, well, what's the answer? Well, let's just try to figure out the last sum as well. All right, so a little bit more. Okay, so 6 plus 7 plus dot, 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 plus 11. Well, that's just an arithmetic sum. So you know that that becomes 17 times 6 divided out by 2. So that becomes 51. And we have the remaining 4 out there. So we got remaining 4. So the answer becomes 55. And this is the answer for AIME number 6.